So here's another example of solving a separable differential equation. I have dy dx is equal to negative 2x over y. My job is to get all the x's on the right, all the y's on the left, and then I'm going to integrate. So to me, I'm going to have to multiply both sides by dx. If you get to the point where you can do this without showing the steps, that's fine. I'm going to show the steps. So this is dy equals negative 2x dx over y. I'm going to multiply both sides by y. Here's what I have. I've got y dy equals negative 2x dx. So all the y's are on one side, all the x's are on the other side, and I have no dy's or dx's in the denominator. So my next step, I'm going to integrate. So I'm going to slap these radicals on here. Put them in red. Not radicals. Integrals. Integrals. So that's my step. I'm going to integrate both sides and see if I can't, when I'm done with that, isolate y. So here we go. The antiderivative of y with respect to y is y squared over 2. And that's equal to, the antiderivative of negative 2x is negative 2x squared over 2, which makes negative x squared. And then my plus c, I only either need it on the left or the right, and you'll find that it's more convenient to leave it over here on the right. So here's my antiderivative, negative x squared plus c. So two things left to do. I have to isolate y. I have to figure out what c is. Typically, I find that it's easier to find c next, except for one kind of separable differential equation that we'll talk about on the backside. So I'm going to use this ordered pair, 1 comma negative 1, to try to figure out c. I'm going to come over here to do that. So y is negative 1 squared over 2 is equal to negative, I'm going to plug in 1 for x, 1 squared plus c. So this is 1/2 is equal to the opposite of 1 squared, which is negative 1 plus a constant. I'm going to add 1 to both sides, and I'm going to get 3/2 equals c. So here's my new equation. Y squared over 2 equals negative x squared plus 3/2. My goal now, get y by itself. So I'm going to multiply everything through by 2 and get y squared is equal to negative 2x squared plus 3. I'm very close. This is exciting. I'm going to move this stuff out of the way. Then I'm going to move me out of the way. And we're going to isolate y. So ask yourself, what's happening to y? This, solving differential equations, is where everything you ever learned in algebra gets to come back and help you. There we go, I'm out of the way, go back to the whiteboard. I'm trying to get y by itself, well, y is getting squared. So I'm going to take the square root of both sides. And recall that that's legit to do as long as this side gets a plus or minus sign. So here I have my almost final answer. Y is equal to the positive or negative square root of negative 2x squared plus 3. And that's cool, except that's not a function. That plus and minus sign, if you actually graphed this, you would get sort of like a sideways parabola. It's not a function. We're going to have to choose either the plus branch or the minus branch. And the way you choose is by using that initial condition. So this initial condition here tells me that if I plugged in 1 for x, I should get a negative result for y. Well, that tells me that using the plus sign outside this radical won't work. I'm going to have to choose the negative branch. So y equals the negative square root of negative 2x squared plus 3. I said you should stop and check. I'm going to change colors. That if I do, in fact, plug in negative 1 for y and 1 for x, I get a true statement. So is negative 1 equal to the opposite of the square root of negative 2 plus 3? Yes, because negative 2 plus 3 makes 1, the square root of 1 is 1, the opposite of 1 is 1, and that is equal to negative 1. So here I have my answer. It's y equals the negative square root of negative 2x squared plus 3. Sometimes you are asked, sometimes you are not asked, sometimes you're asked on the AP test to specify the domain. Remember, we said we're going to have to think about this function, where is it good? This function doesn't have particular branches, but remember that a function is not defined, a radical is not defined in the real numbers if we have a negative inside. So for me, this means that negative, 2x squared plus 3. So the radicand, what's inside the radical, has to be greater than or equal to 0. Right? Otherwise, I'd be taking the square root of a negative number, which will give me an imaginary result, possibly a complex result. So we can't do it. So we're just going to isolate the x here. So 2x squared, negative 2x squared is greater than or equal to negative 3. So 2x squared is less than or equal to positive 3. We have x squared is less than or equal to 3/2. And the solution there, I'm going to scooch. What am I going to scooch out of the way? All right, so if x squared is less than 3/2, that means x is between negative square root of 3/2, that radical should come all the way down, and positive radical 3/2. So my final answer, y equals the opposite of the square root of negative 2x squared plus 3, and that's defined for negative radical 3, let me make this look better. Negative square root of 3/2 is less than x, which is less than the square root of 3/2. Final answer.